With many cars utilizing roadways and that number increasing, there is a need for safe, efficient interchanges. Intentional design can mitigate the number of accidents that occur by reducing vehicle interactions and possibilities of driver error. There are a variety of interchanges that a driver will experience in the United States. We will discuss the physical characteristics and safety aspects of a few that exist. The first type of interchange we are going to cover is the cloverleaf. It is one of the oldest types of interchanges designed for high-capacity roadways and can be found in every state across the country, the first one being constructed in Woodbridge, New Jersey in 1929. The interchange works by connecting two roadways with loops and off-ramps and allowing drivers to access any direction without needing to stop for cross-traffic. The design can range from a partial to a full cloverleaf depending on the traffic demands. If land is expensive or limited, the clovers are considered less effective as they require a large footprint. The cloverleaf design does pose several problems. The main issue is a result of weaving, which is when drivers exiting one roadway have to merge with drivers entering that roadway, causing bottlenecks and increased risk of accidents. In addition, exiting a cloverleaf is often accompanied by a great reduction in speed, which is not always followed. Taking such a tight curve while trying to make such a drastic speed reduction can be dangerous, especially for larger vehicles. When trucks exceed the recommended ramp speed limit, they tend to roll over, resulting in severe accidents. Some solutions to these problems include converting full cloverleafs into partial cloverleafs, known as parkloaves, which help reduce and control traffic in several directions. Another solution is to add collector/distributor roads, which maintain the cloverleaf structure while eliminating the issue of weaving. Even with these solutions, most road authorities have moved towards implementing interchanges that have less extreme curves and avoid weaving.
Our second interchange is the diverging diamond interchange. The first U.S. diverging diamond interchange was constructed in Springfield, Missouri in 2009 between I-44 and Missouri Route 13. It works by switching lanes of traffic to the other sides of the roadway, eliminating all cross-traffic and all cross-traffic turns. Additionally, the system allows for two-phase operation at all signalized intersections, which keeps traffic moving and reduces overall traffic density within the intersection. This prevents backups and bottlenecks and allows for continuous flow and mergers. What truly makes this interchange stand out in terms of safety is that, by virtue of its very design, it eliminates the possibility of car accidents due to oncoming traffic, because there is no oncoming traffic. This means that for all mergers and departures, traffic will always be flowing with you. This reduces overall traffic delays, such as waiting at lights or traffic. It increases visibility and reduces blind spots, and prevents the backup of cars on exit ramps due to the increased flow and ease of merging and departing. With the traditional interchange, cars can pile up on exit ramps, eventually stretching out onto the freeway, which is dangerous and bad, and totally eliminated by this system. The interchange as a whole is designed to eliminate the chances of collisions. There are only 14 spots for potential accidents on the diverging diamond, compared to the 32 spots for traditional interchanges. Now, some might argue that the diverging diamond is too confusing, but that's not really the case. Dotted lines and stoplights allow even unfamiliar drivers to navigate the confusing interchange, while concrete barriers completely prevent drivers, experienced or not, from going anywhere other than where they are supposed to go. A 5-month study after the Missouri diverging diamond interchange was implemented showed a 60% decrease in accidents. Additionally, 97% of drivers said they felt safer in the diverging diamond interchange as opposed to the traditional, and 95% said that they felt the interchange was less congested and more efficient.
The final interchange is the Michigan left. Michigan started using the Michigan left in the road designs in the 1960s, and it is still a key part of their current designs. It was developed to reduce congestion from left turns in an intersection. They are most often used in urban intersections. A Michigan left removes the opportunity for a left turn on a divided highway and replaces it with a right turn, followed by a U-turn further down the road. It reduces collision intersections and increases the traffic flow by roughly 20 to 50%. A Michigan left can be used on routes with average traffic volumes up to 100,000 vehicles per day and can be designed to accommodate large commercial traffic. This style of interchange is much safer than the traditional intersections as seen in other states. A Michigan left reduces collisions by 30 to 60%, depending on the specific interchange. Head-on and rear-end collisions as a result of left turns are decreased by up to 90% in an intersection. Pedestrians have found it safer to cross as the pedestrian cross signals can remain on for longer. There is no measured increase in collisions due to unfamiliar drivers. Weather conditions also do not reduce the viability or safety of a Michigan left. Highway interchanges are an essential part of our infrastructure and are encountered daily by large volumes of vehicle traffic, including commuters. Designing safe and efficient interchanges are essential in maintaining steady traffic flows in both urban and rural areas. Different interchanges hold both advantages and disadvantages when it comes to certain aspects, such as safety and efficiency. Transportation engineers are constantly monitoring and evaluating interchanges and looking for ways to improve them in order to provide a better driving experience for all road users.